Okay, today we are going to carry on with grade 9, Natural Science Term 2, Reactions of Acid with Bases, Part 3, number 3, as we see on our syllabus. And then if you remember, I'm just going to skip this part. We already discussed about this. And I told you that it is a reminder. I want you to answer this question. The slides are on, okay? And then it's in the also in the form of worksheet. I attached, uploaded on Google Classroom. This is your homework until the following week. Next week is holiday, as you know. Until the following week, I want you to complete this. Okay, where I can find the answer for this is you look at the previous classes. Okay, and the slides you can find the answers. This is basically what we need to learn about this long theme or topic. And if you remember in the previous class, we talked about reactions of an acid with metal carbonate base. Metal carbonate is base in this case. I just want to discuss this briefly for the next 2 slides also, and then I can talk about the topic for today. And we know that when acid reacts with base, just look at your screen, please. I'm going to explain this roughly. When acid reacts with base, what happens is it produces salt and water, basically. But this one is also base. Metal carbonate is base. Carbonate is CO3. Can I just highlight here? Look at your screen, please. CO3 is carbonate. And then if you have a metal next to it, okay, this compound is called metal carbonate. And metal carbonate is a base, okay? It has properties of a base, alkaline solution. And when this metal carbonate, example that we need to know is the calcium carbonate, okay? When it goes into reaction with an acid like hydrochloric acid, we said that not the carbonate, the other element, okay, and not the hydrogen, the other element, non-metal part and metal part. So non-metal first, sorry, metal first, non-metal second. As you can see, metal first, non-metal second. When they come together, it becomes salt. So that's going to be calcium, chlorine, not chlorine, chloride, IDE name, okay, name ending, we know that. And the hydrogen here is going to, and the water one. Yes. So when we look at the hydrogen, okay, when we look at the hydrogen here, okay, we were just discussing about this. Hydrogen here, and then the oxygen here, they come together to produce water. And the carbon and oxygen here, they are going to produce carbon dioxide. So this one is a special example of reaction of acid with bases that's producing carbon dioxide gas. And we said that the example is here. Can you see the figure here? If you cannot see, I'm going to explain this roughly, okay? And then let's look at the bigger scale. I just want to show you the bigger scale here, okay? So what happens is that this one is called Erlenmeyer flask, okay? This one is the glass container where we have the chemical reactions, and then you have the hydrochloric acid solution. We said we don't use pure hydrochloric acid. It's very dangerous, so we need a dilute solution of it. Dilute solution means the concentration is very low, like 1 liter, I'm giving you an example, just an example, 1 liter water, a teaspoon or a tablespoon of hydrochloric acid, and then that's what we are going to, how we are going to have how we are going to have the dilute hydrochloric acid solution. Solution is a mixture of water and acid. And when you add this dilute hydrochloric acid solution and plus marble chips, with that one example of calcium carbonate is the marble, and the chips is not the chips that we have, you buy from the shops. Chips means in pieces, small pieces, chips, not powder. Powder, as you can see on the right-hand side, this is calcium carbonate in the form of powder. That's how we can see if you put, if you ground chalk, white chalk, you can get this calcium carbonate. You know that in chalk we also have calcium carbonate. And the marble chips, if you ground it and into small pieces, not powder, and then that's what we call marble chips, you add it in, and then you close it, okay? And then after that, you are going to see bubbles coming up from the surface of the marble chips, which means that the calcium carbonate goes into reaction with hydrochloric acid. It produces salt plus water plus gas. What is that gas? Carbon dioxide gas, CO2. And if it fills in this space, it's going to push all the air here, and then you are going to see some bubbles here, but you are not going to see any color change. And after a while, there will be only carbon dioxide in the Erlenmeyer flask. And then it's going to start moving through the glass tube here, okay? Glass tube, it will go down, go through the way, on the way, and then it will come out here. You can see more bubbles. So these bubbles are now carbon dioxide gas. And then what we can see, what we said is that we can directly use a lime water. We know that lime water is the solution of calcium hydroxide, CaOH2, okay, calcium hydroxide. It looks like water, okay, but there is calcium hydroxide inside. Let's imagine that there is lime water here. Can I just write lime water? Yes, why do we need water? Okay, so why do we need water here is that because the reason is that we want to trap the carbon dioxide gas. Okay, so there is gas coming out. I'm just trying to keep that carbon dioxide, okay, put it in a container. That's why we are using water. If it is in water, okay, it will not escape. So it will just go through here. If there is no water here, the gas will escape into the air on this side, okay? We just want to trap, that's what I'm trying to say. We just want to trap the gas in a container. It cannot go out, okay, into the air. That's why we are using water. And imagine that you are using lime water here directly, okay? Why do we use lime water, calcium hydroxide? Because when lime water, okay, you bubble the lime water with carbon dioxide gas coming from the reaction, okay? They go into reaction, it's going to produce a color like this. Can you see the color here? Okay, like pale white. So when you see that the color of the water structure, okay, the solution here, the solution looks like water. If it turns into a color like this, okay, you say that the gas produced is carbon dioxide gas. If there is any other gas produced, it will not change the color because this one changes color when it is mixed with carbon dioxide gas. Okay, that's what we call lime water test. What do? We trapped the carbon dioxide gas produced. We bubble through the lime water, and the lime water changing from color of water into the pale white, and then we say there is carbon dioxide produced. That's how we observe in chemistry. So today what I would like to discuss is the main topic for today is the reaction of acid with metal. And as you can see on the right hand side, our one of the reactant is magnesium. Magnesium is Mg, okay? Magnesium is Mg. Can I just type here? Okay, sorry. Magnesium ribbon, okay? This one is called magnesium ribbon, okay? On the right hand side, as you can see, this is called magnesium ribbon. Okay, it looks like ribbon, that's why we call it. It's like a thin sheet, and then it's easy that you can break down into pieces, okay? It's not too hard, it's soft, okay? It's a thin, okay, sheet of, it looks like ribbon, that's why we call it magnesium ribbon, okay? When any acid reacts with a metal, as you know that mostly when we talk about acid, we use hydrochloric acid. That's the given example in the syllabus. That's what I want to discuss mainly today. And the products are from salt and hydrogen gas, okay? What is the general equation? Okay, I want to discuss this. And then acid plus metal, arrow is representing the reaction producing salt plus hydrogen gas, okay? So what happens is that if you look at the example, one example, hydrochloric acid plus magnesium, okay? You have the magnesium magnesium ribbon, I was trying to say, and then you have hydrochloric acid solution. Imagine that you have hydrochloric acid solution, you add a piece of magnesium ribbon. This is too much, by the way. If you add a small piece, you can easily identify it. Anyway, and it's going to produce magnesium chloride, and then that magnesium chloride is going to sink at the bottom. As you can see, there are some powdery structure, that's magnesium chloride, and it's going to produce some bubbles. As you can see, the bubbles are coming up to the surface. Those bubbles are hydrogen gas, okay? How do I know these bubbles are hydrogen? Okay, hydrogen gas has got a spatial color? No. Okay, I'm going to do another test like the test for carbon dioxide. There's also a test for oxygen gas. That's what I'm going to discuss in the next slide. And when we look at the balanced chemical equation, HCl is hydrochloric acid. HCl is hydrochloric acid plus magnesium solid. You add the magnesium ribbon, and then it's going to produce magnesium, as we discussed before, similar to the one examples that we discussed before. So not H, the Cl, the non-metal, and the metal from the other side. Mg and Cl, they come together. Mg is on the left-hand side. Cl is on the right-hand side. So the left-hand side is metal. This one is a metal. In the periodic table, I'm talking about periodic table. I'm sure you know what's periodic table. We spend lots of time this. And this one is non-metal. And then when they make salt in which order? Metal plus non-metal. So metal plus non-metal. So it's going to be magnesium chloride. Magnesium chloride. Okay, that's how we can write magnesium chloride. That's our salt. And the H left here is going to turn into hydrogen gas. And when we look at this one, is called balanced chemical equation. Is this a balanced chemical equation? Let's check together. I always throw a line here. Okay, let's check how many hydrogens we have. There are 2 HCls. In one HCl, how many hydrogen? 1. Okay, there's always 1 here. There is always 1 here. There is always 1 here. Okay, and we have 2 HCl. In each way, there's 1. So which means that 2 hydrogen. On this side, how many hydrogen we have? 2. As you can see, hydrogens are balanced on the left and right-hand side of the arrow. And when I look at the chlorine in HCl, there's 1 chlorine. There's 1 here. So, okay, no number 1. And if you have 2 HCl, in each there is 1. In 2, there's going to be 2 in total. 2 Cl, and there are 2 Cls here. Okay, the chlorine is also balanced. And the magnesium Mg is, there is 1 here, and Mg there is also 1 on this side. So which means that I can easily say that on both sides there is equal numbers of hydrogen, equal numbers of chlorine, equal numbers of magnesium. That's what we call, as if you remember, the conservation of atom. If 1 hydrogen goes in, 1 hydrogen goes out. 2 chlorine goes in, 2 chlorine goes out of the reaction. And if I ask you the reactants and products, okay, I just want to discuss this, okay? This is one of the challenging points that we had in the test. And what are reactants? Which ones are reactants? Which ones are products? On the left-hand side, we know that we always have the reactant or reactants. The reactants, okay, sorry, can I just spell correct? And on the right-hand side, we have products, okay? We assume that on the right-hand side, it will be only products. And what are the reactants for this reaction? Hydrochloric acid, magnesium. What are the products, if I ask you, what are the products for this reaction? If I ask you, you can tell me magnesium chloride, salt plus hydrogen gas, okay? As you can see, the powdery structure going down, okay? This powdery structure going down is magnesium chloride or dissolves in water. And can you see these bubbles coming up? Those are hydrogen gases. That's what we produce during this chemical reaction. And investigating reactions of acid with metals by reacting dilute hydrochloric acid. Dilute means the concentration is low with magnesium. Test for hydrogen gas. That's what I'm going to show you in the next slide. So we should know that a glowing splint is used to test. Okay, you can use a glowing splint. I'm going to show you what is that. Or a piece of wood, okay, you put it on a fire and then there's a flame on it and then you put it in the test tube. If you keep the gas in the test tube, and that's going to tell us about the presence of hydrogen gas. Did I produce hydrogen during this? What is the type of gas? There's bubbles coming up. Yes, gas is produced, but what type of gas is this? I'm going to use popping sound test. And I like to call it hydrogen gas test. I like to call it hydrogen gas test, okay? So you have the magnesium ribbon, as you can see here. And what you do is that, you put it into the dilute hydrochloric acid. This is not water. And after that, they go into reaction. As you can see, the bubbles are coming up. And what do? You just close the test tube, okay? You just close the test tube, this test tube like this. These are some diagrams, pictures that I found from internet, okay? And then after a while, when you see the reaction is over, what you need to do is you just remove this rubber, okay? And then close with your fingers, okay? And the gas cannot escape. And then you just bring what we call this, I just want to highlight here. You just need to bring, that's what we call here, glowing splint, okay? Or you can bring a match. You must just be careful when you deal with the match, like the long ones, for example, if you have the long match, and then you just put it on fire, okay? You just put it on fire, the match, as you can see, just dip it into that. If you hear the popping sound, pop, pop, okay, not too high, not too high, because the amount of hydrogen gas is too small here. Okay, that's why it's not going to cause any problem. You must just be careful when you handle with acid. Acid will spill. Okay, it's in a test tube. Better to leave this in a test tube holder, and then you have your enough equipment to protect yourself, PPE. Okay, and then you just hold it with a gloves in your hand, and then you must have your googles. Okay, you must have your googles on it, and then you just put it inside, and when you hear the pop sound, that means the hydrogen gas. Why? Because hydrogen gas is explosive gas. It's an explosive gas, and you produce an hydrogen gas. That's how I can understand. So this is what we call hydrogen gas test. Okay, and this is your homework for those people who didn't complete. You don't have to submit this. I want you to do it yourself on your notebook, and then I want you to check it yourself. How can I check it? You can search on internet, but I have all of these okay, answers on the previous class slides. So you just need to go onto the summaries and then check the answers yourself, and that's your homework for the next week. Thank you very much.